Hi everyone. In this video, we are going to be talking about one-to-one functions. These are a very special type of function. One of the reasons they're so special is that we're able to find inverses of these functions. And that is where you're able to find another function that maps all of the points in the function's image back to the domain of the function. Okay? You can't do that with all functions, and we'll show why that is here in just a minute. So the definition of a one-to function goes as follows. It's a function. A function is one-to-one if and only if no 2 points on the graph have the same y-coordinate. So we're defining this in terms of the graph, but we can also define this in terms of relations. Let's take a look here at these two different relations. Here we have 1, 2, 2, 2, and 3, 2, all in this first relation here, okay? This is a function, okay, because each x value is being sent to some y value, okay, and there's no like the one isn't being sent to two different values, two isn't being sent to two different values, three isn't being sent to two different values, so we can say that is a function, right? But it is not one to one. This is not one to one. Okay, and the reason it's not one-to-one is because we have repeating y values. Matter of fact, we have all the same y value, okay? So this is not a one-to-one. But this one here, we have the point 1, 2, 3, 4, and then 2, 6, okay? So what we're seeing here is there are no repeated y values. We have 2, 4, and 6, and then each, it is a function because 1 goes to 2, 3 goes to 4, and 2 goes to 6, okay? But there are no repeated y values. So we would say this is a one-to-one function. Okay, so this is how we can think of one-to-one functions. And this property allows us to have another type of test. But previously, we've talked about the horizontal line or the vertical line test. Now we're going to be talking about the horizontal line test. This is used to determine whether or not a function is one-to-one. Okay, so it's the exact same principle except now we're using a horizontal line. So if you are able to draw a horizontal line anywhere along the graph of the function and hit more than 1 point, then it is not one-to-one. So for this first example here, if we draw a line through here, see we hit 2 points on the graph of the function, so this is not one-to-one. Okay, if we look at this one, move these, so lost the arrows there. And if we look at this one here, there's nowhere that we can draw a line anywhere on here that hits more than 1 point. There's nowhere we could draw a horizontal line that hits more than 1 point. So therefore, this is a one-to-one function. Okay, let's take a look at this example. Here, really everything to the left of this point and this point here is obvious, and everything to the right of this point here is obvious. Much like the last one, we can draw lines through here, and we're not going to hit more than 1 point. But the problem there, the potential problem area, is these 2 points right here. Okay. However, we're good because this particular line segment here does not include that endpoint. But this line segment does include that endpoint, okay? So we're good. We could draw a line through here, and we're still only technically hitting 1 point because we're not including that endpoint there. So we would say this one is a one-to-one function, okay? So this leads us right into our next topic, which is inverse functions. This is something we're able to do with one-to-one functions is we're able to find their inverse. Okay, so let me show you the connection here between the one-to-one functions and inverse functions. If we take this first example, okay, let's go ahead and highlight everything. Okay, and let's just rotate this on its side. Now we have the vertical line test, okay? This would fail the vertical line test, okay? This particular one would fail the vertical line test. So if we turned it on its side, it's not a one, it is not a function anymore at all, okay? So because each of the y values are not unique, we're not able to map each of them back to their initial um, x value. Okay, so this one wouldn't we're not able to find an inverse with it. But if we take this particular function here and we rotate it on its side, without grabbing the other graph here, if we take this particular function and we rotate it on its side like this, we find that it actually passes the vertical line test again. We rotate it on its side. Therefore, we can take all of the values on the graph of this function and map them back to their original x values. So we will be able to find an inverse of this function. So let's maybe let's see if we can figure out a way to at least determine if two functions are inverses of each other. Later on, we're going to actually figure out how to find an inverse function. But for now, let's just look at some of the mechanics on how this works. So here we say that two functions f and g are inverses of each other if and only if f of g of x is equal to x for each x in the domain of g, and g of f of x is equal to x for all x in the domain of f. And again, we're assuming up front that all of these are one-to-one functions. They are, in fact, one-to-one functions. But on this homework section, you don't necessarily have to worry if they are one-to-one. You are assuming that they are. All right, so let's check and see if these two functions, f of x equals 4x and g of x equals x over 4, let's see if these are one-to-one functions. Now keep in mind, you have to double check for both of these. You can't just do one. You have to do f of g of x and g of f of x. Okay, so let's check f of g of x. Okay, f of g of x is the same thing as f of x over 4, because we said g of x is equal to x over 4. Okay, so anywhere where we see x in f of x, we're going to put a x over 4. Okay, so this would be 4 times x over 4. And what we'll see is that these 4's cancel, and we're left with x. So for that direction, f of g of x, we are good. Okay, so if we get the other direction, we're going to have that these two functions are inverses of each other. So let's try the other way. So here we have g of f of x. Okay, so this is going to be g of 4x, which will be 4x over 4. Okay, and these 4's will cancel, and we're left with x. So because we get x back for each of these compositions, we can conclude that f of x and g of x are inverses of each other. Okay? It's not always true. So let's take a look at this example. Here we have f of x and g of x, where f of x is equal to 2x plus 1, and g of x is now equal to x plus 1 over 2. So let's go ahead and try the first direction, f of g of x. So here we have 2 times x plus 1 over 2 plus 1. So let's go ahead and distribute everything. So if we distribute this, we get 2x plus 2 over 2 plus 1. Okay? Now we can pull a 2 out on top here, and we get x plus 1. And these 2's will cancel. And now we're left with x plus 1 plus 1, or x plus 2. So that's as much as you can simplify that, and therefore this direction does not work, and therefore we have that this is, we can stop right there. We can say this is not, these two functions, f of x and g of x, are not inverses. Okay. And you may get that one direction works and the other doesn't. That's fine. And you may get that both directions don't work, or you may get that both directions do work. All three of those are possibilities. So it is worthwhile to check both directions. So this hopefully was a good brief introduction to one-to-one functions and to a little bit of their applications, which is inverse functions.